Hello everyone, welcome back. Today we're going to be taking a look at creating a calculator in our Ruby beginner series. As a reminder, in previous videos, we've covered creating additional files, we've covered for loops, we've covered functions, we've covered while loops and getting user input. Today we're going to try and put some of this together. Let's start by considering what a calculator should do. So what I'm going to say is we want a calculator that can do the following. First, addition, then subtraction, multiplication, division. It should get user input, and then it should print the result. We also want to continually ask for input. So a user can do multiple calculations per run. Let's also say a user can quit by typing Q or Q, like lowercase q. So these are just some things that I'd like to do. What I'd like to start with is by just creating a basic calculator, and then we'll do some refactoring where we gradually improve it. To get started, let's say we want to have a main method. I'm going to go ahead and call the main method. I'm then going to create the main method by just saying def main. Inside of here, what I want to do is say the user should start by getting a message that says welcome to the calculator, just like this. I'm going to get rid of all of this stuff it just printed because that feels like cheating. I'm actually going to full screen this for now. So what I'd like to do is allow the user to choose addition, subtraction, multiplication, division, and then quit the program. So what I'd like to do now is say the user has a command, right? They've issued a command. The command is equal to gets.chomp.downcase. We're going to be downcasing this just in case the user sends us something like capital Q for quit. We just only want to check for a lowercase q. After we've done this, we can then say, all right, if the command is Q, we should just puts goodbye. The return keyword here allows us to break out of this main method and just return so that we don't have to continue doing anything else. This is almost like it's guarding us from doing the rest of the program if the user puts in a Q. Now, the way this is going to work is we're going to do this so that the user runs the calculator one time. And then after we figure out what it's like to run it one time, we'll then implement the feature that allows it to run a bunch of times. So we'll just start with this. It won't make a lot of sense for how this will run a lot, but hopefully if we write this well enough, we'll end up in a situation where we can then say, all right, let's just loop through this a bunch of times. So now that we've done this, we need to say, all right, if the user's command, if the command was equal to the number 1, then we want to say they've chosen addition. If the user's command was equal to 2, we can say they've chosen subtraction. We're using else if statements here. 3 will be multiplication and 4 will be division. Puts, I don't understand that command, is just if they put in like the word test, because that's really not an option here. Let's go ahead and let's take a look at what we should do here. In all of these cases, we probably need to make sure the user can just enter a new or a first number and a second number. For this case right here, let's just go ahead and let's return because we don't understand what they want us to do. So we shouldn't even ask them for the numbers because it doesn't really make sense. So now let's say puts, what is your first number? We can say first number is equal to gets.chomp.to, and you have a choice here. You can either use 2i for integer or 2f for float or decimal. Let's use 2f. We can then ask them for the second number. And then we could say second number is the same thing. Now that we have both numbers and we know they want to use addition or subtraction or multiplication or division, we're good to go. So let's go ahead and let's do this. We'll come down here and we'll say if the command is equal to 1, then we know it's addition. In that case, we could start by doing a result is equal to first number plus second number. We can then go ahead and print the result. We can do an else if command equals 2, And you can see this is actually very similar to what we have right here. So I'm going to go ahead and copy this. We'll paste this in. We don't have this else statement down here because this is a different block of code. If the user chose subtraction, we're going to do pretty much the same thing we had here, but we need to change this to a subtraction. If they chose multiplication, we'll do the same thing. And we'll say this is a multiplication. For division, we'll do the same thing, but we'll change this to a division symbol. Now we have all of these done here. We've now asked the user for their input. They've given us a proper input, hopefully. They've then given us a first number and a second number, and then we've managed to print those results. Let's go ahead and let's try running this. Ruby main.rb. Welcome to the calculator. What would you like to do? I'll start with addition. You've chosen addition. What is your first number? 5. What is your second number? 5. Gives us 10. Now let's take a look at what we have here. We have a command block that's printing off a bunch of stuff for basically no reason. We then get 2 numbers using pretty much the same logic. And then we have a if statement again that mirrors our first if statement. Let's think about how we can take this and break this up a bit. Now, we have 2 options. One is to break these up into individual functions, and the other one is to loop through all of this stuff. Let's think about what looping through everything would look like. If we loop through everything, we have to do a couple things multiple times. We have to show the user, welcome to the calculator. We're going to have to get the user's command. We're going to have to check if the user wants to quit. We're then going to have to tell the user, all right, what's your first number? What's your second number? Or I don't understand. And then we're going to have to do the mathematic operation. After we do that, we then loop back up here. We start again, and then we're going to have to say, here's your options. What's your command? So really what we could do here in our main function is we could just say, while true, do everything inside of here. Tab all of this over, and then hit end down here. We basically have a working calculator. Sort of. Let's try this. We'll say ruby main.rb. Let's type Q to quit, and you can see goodbye. Let's run it again. Let's do addition. First number's 5, second number's 5. We get 10.0, and then a welcome to the calculator. So really what we need to do here is when we print this final result, we should actually be using puts, not print, because we want a new line there. It's my fault for using AI instead of typing this myself. Let's go ahead and let's try this again. Let's print addition. First number 5, second number 6 is 11. We then welcome to the calculator again because we print that, and then we go back up to the top to start over again. We could actually take pretty much all of this and just turn this into a calculator loop. Let's cut this and let's call a calculator loop. And then let's create another function here, def calculator loop. And then in here, we can just paste in our entire logic. So we now have our calculator loop, our main function, which calls calculator loop, and then we start by calling the main function. Looks a lot cleaner like this. But of course, if we expand this, we can see everything that's in here. Let's take this and let's move this into a print welcome message. We can then come up here and do a def print welcome message. And then we can just paste all of this in. We also have the input that we're getting here. We have the user input, and then we're checking if they want to quit and some other stuff. This is where we want to be careful about how we're breaking these things up into various functions. The issue is when we return here, we're returning or we're breaking out of this while loop. If we move all of this stuff into a separate function, we would only be returning out of that function. Let's take a look at what I mean. I'm going to run the program by typing ruby main.rb, and I'm going to type Q to quit. You can see here that gives us goodbye. Let's take this logic right here and let's move this. Let's call this, I don't know, get user input. Just like that. We can then come up here, do a def get user input, and we could say command is equal to gets command. If the command is equal to Q, we want to puts goodbye and return. If the command is equal to 1, 2, 3, or whatever, we then want to print this stuff out. If you don't understand, we print don't understand, and then we return. So this is what our get user input looks like now. When we call get user input here, if we run this, we can see we get our welcome message. I'll type 1, I'll hit enter, and it says you've chose addition. What's your first number? We can say, all right, our first number is going to be 5. Our second number is going to be 6. We can see here we get an error. Undefined local variable or method command for main object. Why is that? Well, we get our command in our user input function. We check all of these things. It prints addition, so it looks like it's working. But when we get down here in our calculator loop and we say if command is equal to 1, this command doesn't exist anywhere in this calculator loop. It actually only exists in this get user input. So once we're done in this get user input, we actually need to return this command. If we try this method and now run this, we can say 1 is addition. We can type in our first number and our second number, and this still won't work. The reason is our command is still undefined because we're returning it, but we actually need to also get it here. So we need to say command is equal to get command from the user input. If we now run this, type 1, type 5, type 6, you can see it gives us 11, and then it runs the loop again. So this is where you want to be a little bit careful, just in case. But okay, this seems to be working for us. I think we actually don't even need this check here for putting all of the addition, subtraction, multiplication, or division operators. What I want to do is say if the command does not equal 1, or the command does not equal 2, or the command does not equal 3, or the command does not equal 4. But notice, if we have the or here, what's actually happening is we're saying if the command does not equal 1, or 2, or 3, or 4, we'll actually run into an issue when the command equals 2, for example. The command does not equal 1. This is true, which means this will print before it even checks if the command does not equal 2. So we actually have to use the and operators here and not the or operators. This is a bit of a trick that you can fall into where if you use the wrong operators, you can enter this loop without realizing it. But you'll also realize something else. If we run this program now and we type 1 for addition, you can see our first number is 5, our second number is 6, that prints 11, that works okay. But what happens if our our command is equal to 6? You can see, I don't understand that command. What is your first number? Why is it doing that? Well, you see, we've run into this problem where if our command fails here, we print that we don't understand, and then we just return nothing. And instead of this breaking us out of the while loop like it did before, it's actually just returning nothing and then putting nothing into our command here. So what we actually have to do here is return something, maybe like return 0, and then we have to say if command was equal to 0, then we have to go to the next iteration of this loop. The next keyword, as a reminder, takes you through all of this, skips it, and then starts the loop again. It's not really ideal to be returning 0 from something like this. This is an instance where we really just want to not have to do this type of logic. This is also where you probably wouldn't want to have these pieces of logic in the get user function. This might make more sense as like a validate user input function. So let's do that. Let's take this command, move it out of here. And now all we're going to do is say if our command is equal to Q, we'll put goodbye and return. But we'll deal with that in a second. Let's now do a validate check. So we'll say if invalid command, we'll pass in the command. If invalid command, we will just print next. Then let's come up here, do a def, and we'll say invalid command. This will take in a command, end, and then in here, we'll say if the command does not equal 1, and it does not equal 2, and it does not equal 3, and it does not equal 4. I don't want to return that I don't understand the command. What I actually want to do is return true. I want to return true that these conditions have failed. If these conditions have failed, this will return true, which means if next, and then we can go to the next loop. And in here, we can of course put whatever error we want. We can say puts, I don't understand that command. And now let's try running this. Ruby main.rb, I'll type in the number 6. I don't understand that command. It then says that was invalid, so we'll go to the next iteration of our loop. Cool. But you'll notice that there's another piece of logic we don't quite have, and that's our if command equals q bit. We can use the same type of logic here. Let's say def check for quit. Check for quit. This takes in a command. And then in here, we grab this bit right here, cut it, paste it in here. And then instead of just returning, we can just say return true. And then down here, we can say if check for quit command, then we want to break. We're using next here because we want to do the loop again. And we're using break here because we want to break out of our while loop. Let's go ahead and let's try running this. If we try running this and we type Q, you'll see this doesn't work. But what's actually happening here? Well, if our command does not equal 1 or 2 or 3 or 4, we don't understand it. So Q does not equal 1, and it doesn't equal 2, and it doesn't equal 3, and it doesn't equal 4. So it tells us it doesn't understand. And then it goes to the next iteration of the loop before we check for quit. So we also need to add something in here that says, and the command does not equal Q. And now if we run this program again and we type Q, you see goodbye and our program quits. Now this right here is kind of ugly because we have a bunch of different conditions inside of our if statement. Let's try something else. Let's take all of these and let's say command equals number is equal to this conditional right here. If the command, or I guess we should say command does not equal number. If the command does not equal the number, then we have this condition. We also have the quit condition here. So we could say command is invalid is equal to command does not equal number and command does not equal quit. We can then use command is invalid here as our check. If command is invalid, puts I don't understand that command, return true. This allows us to keep these things in our variables. It's still not the best way to do this, but it is a beginner calculator. So that cleans up our code a little bit. We can then run this, test it, 2 for subtraction, 6 and 5 gives us 1. We can type Q to quit, all of that's working. We have our print message, our command, we check for invalid, check for quit. Let's get our user numbers. Let's say get user numbers. This then comes up here. We can do a def get user numbers, get our numbers, and then we need to return the first and the second number, which means here we need to do first number, comma, second number equals get user numbers. So now we have our numbers here. Let's then do our math operations. Our math operations need to happen in a couple different ways. Let's start by abstracting these a bit. Instead of doing first number plus second number, let's do add first number and second number. We can do the same thing here for subtract. We could do another one here for multiply, and we could do another one here for divide. That helps to clean up our code a little bit in case we want to change how these math operations work. We do need to define these. So let's come up here and let's do it before the calculator loop. Let's do a def add for first number and second number, one for subtract, one for multiply, and then one for division. You'll see why we're doing this in a second. Let's go ahead and let's try running this code. Run this code, addition, first number is 5, second number is 6, that works. Let's try division. First number is 16, second number is 4, that works. But now let's try something else. Let's run this program one more time. Choose division. Let's divide 25 by 0. You can see here, this gives us infinity. Now, 25 divided by 0 probably shouldn't be infinity. What we want to do here is say that's not really how math works, right? Let's move these prints into our actual math operations. We can do that by, instead of returning a result, we can just print the result in here. After we do that, we then have the ability to turn all of this into one line of code. And then we actually don't need to do this result either. It gives us a much cleaner version of our if statement here. We can then do the same thing we did before, where we run all of these. We get 11, that works. But now, in the case where our second number is 0, we can actually say if second number is equal to 0, puts you can't divide by 0. Return. End. You can also do else and then put in this logic right here. This allows us to do our check, and then we should be good to go. If we try running this, we'll do 4 for division. We'll type in 25 divided by 0. You can't divide by 0. So now we have our error handling. And you'll notice that happens here, even though we're calling the function, we can handle that logic ourselves by modifying how the math works. We're not necessarily changing the rules of addition or subtraction, but we're being a bit better about how we handle these errors, right? So that takes care of that. Let's hit Q to exit. Let's go ahead and let's move this right here into its own function as well. Let's do this as the calculate method. This takes in a first number, a second number, and a command. We can come up here, do a def calculate, run this loop, and then be done here. So now our main loop, our calculator loop, is pretty much just this while loop that has a couple of steps in it. It's pretty easy to see what we're doing here. We're saying print the welcome message, get the user input, check if they gave us an invalid command, check if they want to quit, get the first number and the second number from the user, and then calculate. That seems fine. But our code is about 100 lines in this file, which does make it a little bit hard to read. Let's go ahead and let's refactor this a bit more. Let's come into our file here, create a new folder, call this math. Inside of the math folder, I want to create a new file. I'm going to call this, I don't know, operations.rb. Inside of operations, I want to put in the divide, multiply, subtract, and addition stuff. I'll take all of this, I'll put it into operations. This seems a bit cleaner. I can now come in here, and at the top, I'll just say require relative math/operations. That still allows us to use this file. It's just moved into this folder. First number 5, second number 6, that gives us 11. So that's pretty cool. What else can we move in there? Let's go ahead and let's do the input for the users. Create a new folder, call this like input. And then in here, we'll just say this is for like user input.rb. In here, we'll say anytime we want to get user input, we'll grab it from here. So let's move in our get user numbers. And I think we have our get user input, just like that. And now we want to require relative our input as well. We can do another one, create a new folder, call this validations. In here, we'll just say new file, validate, input, or something. And then in here, we'll do our invalid command, just like that. And I think that's it, right? Yeah, it looks like it. We'll save that. And then we need to require relative that validations validate input. Go ahead and remove all of this empty space that we don't need anymore. And now our code's looking a little bit cleaner. We're now down to 68 lines here with these things in multiple different files. we have our loop, we have our calculate, we have our check for quit. At this point, I would say you could probably go through and clean this up a bit more. We run this, we check for addition, 5 and 6, that still works. Q still works to quit. I think it would make sense to move some of the stuff into another folder. Maybe we could have like a folder for our loops, like our main program folder, or main logic or something. I would say that would make a good exercise for the viewer. You've now worked through a pretty involved program. I would argue it's more involved than it probably needs to be. Like this is just a simple calculator that we've probably over-engineered. But I'd say let's maybe try to move the calculate, the check for quit, and the prints into a different folder or different file. I'm sure you'll be able to figure it out. It's going to be very similar to the other steps we've done here, but this is a good way for you to check and, more importantly, hopefully, to run into problems. Running into problems is where you do most of your learning. It's not from following along with people like me. So hopefully, as you try to move these things into a different file, something goes wrong, and then you have to fix it yourself, because that's where you'll actually do your learning. But for now, thank you so much for watching, and hopefully I will see you in the next one.